Hello students, welcome to Learner's Planet, problem solving session 4 of carbon and its compounds. In this session we will be solving questions related to the homologous series and also about the properties of the hydrocarbons, their combustion property, the addition reactions which hydrocarbon give, and the substitution reactions. So now let's start our problem solving session. Our first question here is calculate the difference in the molecular formulae and the molecular masses for. Now here students, we have got two molecules. One is C4H9OH and another one is C3H7OH. So from both the things we can say that these molecules belong to the similar homologous series. Why? Because they both have got what group? Hydroxyl group. Now we know that the difference between the two homologues is of how much? CH2. Right? So what is the difference in their molecular formulae? The molecular formula difference is CH2. Okay? And what is the difference in the molecular masses? So you don't need to calculate the molecular mass of C4H9OH separately and C3H7OH and then subtract them. Actually, there is no need of it. We know that the difference in the molecular formula is of CH2. So what will be the difference in their molecular weights? It would be 14 only. Okay? So don't waste your time summing up the masses of carbon, multiplying of hydrogen, of oxygen, and again hydrogen, and then subtracting. Just use some logic here. Say if I'm saying that calculate another such sort of question, if I'm saying that calculate the difference in the molecular masses of C5H11OH and C9H17OH. Now here students, you can see that these also belong to the same homologous series. You first try to find out the difference in their molecular formulae. What is the difference between them? How many carbon atoms are more? The difference is C4. And how many hydrogen atoms? It is, isn't it the difference C4, C5? There is C6, 7, 8. 3 carbon atoms. There is the difference of, this is the 5th member of the homologous series and this is the 9th member of the homologous series. So between them, how many more CH2 would be there? If I'll add one CH2 to C5H11, it would be C6. Another CH2 to C6, it will become C7. Another CH2 to C7, it will become C8. Okay, and another CH2, so it will become what? It will become C9. Right? So what will be the difference in their molecular masses? It would become, how many hydrogens are there? So students, what is the difference between these? How many CH2s are there between them? 4. Now is this formula should be C4 C9H17OH. Okay, so it should be H19OH. How? That is C9H9 multiplied by 2 plus 2 minus 1, right, and OH. So what it should become? 9 multiplied by 2 is 18, plus 2 is 20, minus 1 is 19. So formula should be C9H19OH. My mistake. So how many CH2s are different here, students? There are 4 CH2s. Okay. So what should be the difference in their atomic weights or molecular masses? Sorry. 14 plus 14 plus 14 plus 14. How much it should be? 4 plus 4 is 8, 8 plus 4 12, 12 plus 4 should be 16, and 1, 2, 3, 4, 5. So what is the difference between the molecular masses of C5H11OH and C9H19OH? It is of 56, right? So here I just gave you this example because you don't need to sum up the masses of the atoms and then subtract. Okay, now let's take up our next question here. It is the next homologue of C5H11OH is. Just tell me what would be the next homologue. In the next homologue will differ from C5H11OH by CH2. Okay. So what would be the formula of next homologue? It should be C6H13OH. Right? So this is the next homologue. What would be the next homologue of this molecule? It should be C7H how much? 15 and OH. Likewise, we find out the homologues. Now our next question here is, students, give the IUPAC names of CH3COOH. So, what should be the name of CH3COOH? CH3COOH. How many carbon atoms are here? 2. What should be the root word? Eth. What type of bond here is there between the 2 carbon atoms? Single bond. What should be the suffix? N. What is the group here? Carboxyl. Carboxyl groups are named as oic acids. What should be its name? Ethanoic acid. Its common name would be acetic acid. Now our next compound here is to be named as C4H9COOH. Again, the number of carbon atoms, 5. So, pent. Then, the number of bonds, the type of bond between the carbon atoms, N. The group present, oic. So, pentanoic acid. Okay? Now, the next compound, what it is CH3CHO. How many carbon atoms? 2. Root word eth. Bonds between them single. So it should be N. And what is the suffix for aldehydes? It is al. So it should be ethanol. Okay? So this is how we name the compounds. I hope you are through with the nomenclature now. Now this question is, what are the products formed in the given reaction? What is your reaction here? It is C7H16 and it is undergoing a combustion reaction, that is, it is burnt in air. So what should be the products formed? Whenever a hydrocarbon is burnt in air, what we get? We get carbon dioxide and water. Now how to balance it? Accordingly, I should get 7 CO2 and 8 H2O. Right? So how many oxygen should be here? 14 plus 8. How much it should be? This is 14 oxygen and this is 8 oxygen. So it should be 22. Okay? So I can make it 11 O2. Now your equation is balanced. So students, it can be any hydrocarbon. Say I am having here C5H10 is burnt in oxygen. It is an alkene. I hope now you know what is an alkene and alkyne. This will also give me carbon dioxide and water. If I am taking an alkyne, C5H8, I am again heating this, but for this you require a large amount of oxygen. Okay, so what should be the product here, students? It should be again the carbon dioxide and H2O. Right? So whenever a hydrocarbon is burnt in oxygen or combustion reaction, we get carbon dioxide and water. Now let's take up our next question here. What are the products formed in the given reaction? It is C3H7OH plus oxygen. What is the C3H7? C3, it's 3 carbon atoms, that is prop, and it is propanol. When propanol is burnt, what we will get? Say your C3H7OH plus O2, and the combustion reaction is here, and what we will get? We will get carbon dioxide and water only, that is thrice of CO2 plus 4H2O. You need to balance the equation. How many oxygen are this side? 6 plus 4, 10 oxygen atoms. How many oxygen atoms are this side? 3 oxygen atoms. So what can we do? We can just make it even. We can make it 2 C3H7OH and we can make it some 5. Okay? If I am making it 2 C3H7OH, right? Now what I will get this side? I will get 6 CO2 plus, how many hydrogen are there now? 8 hydrogen and 2, so 16, so it should be 8 H2O. Now the number of oxygens are 12 plus 8, that is 20. Okay, and now we've got 2 here, so I can make it 9 O2. Now our equation is balanced. So whatever is the organic compound, students, it can be an aldehyde or a ketone or an acid or an alcohol or an ethene or an alkyne. You burn any of them in the oxygen and the products obtained would be carbon dioxide and water. Now let's take up our next question here. Which of the following hydrocarbons will give substitution reactions and why? Substitution reaction, that is, one of the hydrogen has been substituted, like your, if I'll take the CH4, treat it with chlorine in the presence of sunlight, what would be the product obtained? This is light. What will be the product obtained? CH3Cl plus of HCl. This is what? This is an example of substitution reaction. Okay, now let's check out what can give substitution reaction. So it can be given by alkanes. Right? So substitution reactions are given by alkanes. Now just check out what all are the alkanes here. C2H6 is an alkane. C3H6, is it an alkane? No. C3H6 is an alkene. I have told you many times. Now I am not going to write the general formula again. C3H8, is it an alkane or alkene? It is an alkane. C4H6, what is it? Is it an alkane or an alkene or an alkyne? It is an alkyne. Right? Then is C5H12. This is again an alkane. So all the three of them will give what type of reaction? They will give substitution reaction. Okay? So this is your substitution reaction. This is the way we find out. Alkenes and alkynes can't give substitution reaction, students, because they themselves are deficient. If I am writing C3, so there is a double bond here. They themselves are deficient. How can they give out more of the atoms? So substitution reactions are given by saturated compounds. Now our next question here is, which of the following will give addition reaction and why? Now students, your addition reactions are given by unsaturated compounds. That is, it can be an alkene or an alkyne. Now let's take up this C3H6. What is it? It is an alkene. It will give addition reaction because it has got a double bond. So if I am treating this alkene, of course there will be H. I am not drawing those H. And if I am treating this with hydrogen in the presence of nickel catalyst, what I'll get here? I'll get an alkane, that is CH3. Previously it was CH3, CH double bond CH2. After addition of hydrogen, I'll get CH3, CH2 and CH3. Okay? What else is there? C4H8. What is it? This is also an alkene. And it will give addition reaction. C5H8 is what? It is an alkyne. And this will also give addition reaction. C6H14 is an alkane. Will it give an addition reaction? C6H14 is what? Is an alkane, and it will not give addition reaction. Now C8H18 is again an alkane, and this will also not give addition reaction because they are alkanes. They'll undergo, where are they going to add? C6. They all they are saturated compounds. Say if I write the formula of hexane, it would be CH3, CH2, 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 CH2. Okay. and again CH3. So where are they going to add? So they are not going to give your this thing addition reactions. So what are giving addition reactions here? Butene, pentene and propene. Okay. Now let's take up our next question here. It is, what are the products formed in the given reaction? Now what is C5H12? C5H12 is an alkane and its name is pentane. It is treated with chlorine in the presence of sunlight. So what type of reaction it will undergo? It will undergo substitution reaction and it will form C5H11Cl. So what will be its name? Its name would be pentyl chloride. Likewise, if I am taking butane, C4H10, and I am treating this with chlorine in the presence of UV light or simply light, what I'll get here is C4H9Cl, that is butyl chloride or chlorobutane, right? This is the way the reaction takes place. Now let's take up our next question here. What are the products formed in the given reaction? Now here, students, this reaction can be used as the test for unsaturated compounds. Why? Because your bromine water, due to the presence of bromine, has reddish brown color. Okay. Now, when the C2H4, this is hydrogen, this is hydrogen, here is hydrogen and here is hydrogen. This is treated with Br2 water. What happens? That it is an unsaturated compound and it undergoes addition reaction and it forms CH and this is Br, C, Br, this is H and this is H. So what it would be, this is dibromoethane, right? Or 1,1,2-dibromoethane. Now what has happened? That the color of the bromine water gets decolorized. So all the alkenes or the alkynes, they decolorize bromine water. Remember that. This is a test for unsaturated compounds. So if I am taking an alkyne here, alkyne say CH3, this is C triple bond CH. I am treating this with bromine water, Br2. What I'll get here? Here is CH3C Br, a double bond, and CHBr. Again your bromine has been cleaved and your bromine water gets decolorized. So the unsaturated compounds decolorize bromine water. Okay. Now let's take up our next question here. What are the products formed in the given reaction? What is happening here? This will undergo what? Addition reaction. Why? Because it is a double bond here. So what will be the product obtained? I'll write the product here. It should be CH3H, and there is a double bond over here, that is C. Okay, there will be addition of a hydrogen, and there is again a hydrogen and C2H5. So this is H and this is C2H5. So what we have got? We have got a saturated compound. Now if I want to name this, what I can do is I'll write it in the chain form, that is CH3, CH2, CH2 and C2H5. Right? What should be the IUPAC name of this compound? How many carbon atoms are there? There is 1, 2, 3, 4 and 5. So it is pentane. Okay. Now here what was it? If I am numbering this 1, 2, 3, 4 and 5. So this would have been what? 2, or it can be pent-2-ene. Okay, so this is the reaction for the conversion of a unsaturated compound to a saturated compound. Now let's take up this question. Cooking oil decolorizes bromine water but butter does not. Why cooking oil is decolorizing? Why cooking oil is liquid in state at room temperature? Why is it so? Because your cooking oil contains unsaturated hydrocarbons. Right? And your butter, it contains saturated hydrocarbons. So always remember, whenever there is a question like this about related to bromine water, right, or the decolorizes potassium, similarly your the unsaturated compounds, they decolorize the potassium permanganate solution also. Why? Because our 1% potassium permanganate solution is called as Bayer's reagent. Okay, now that Bayer's reagent has got a light pink color. Now this unsaturated compounds decolorize 1% alkaline KMNO4 also. Now this is called as Bayer's reagent, but saturated compounds do not. So you can get questions like this, say cooking oil, it was just an example. Your vanaspati ghee, it will also not decolorize Bayer's reagent or bromine water. Why? Because it has got saturated fats. Okay, so now I'll conclude this lecture, students. I hope you enjoyed this session, and we will be solving questions related to ethanol in our next session. Thank you for listening patiently.